Okay, here we go. We are about to jump into another video this one's going to tie together some math that we've been learning throughout secondary school with what's happening in our modular system, which is super cool. We're doing all this stuff and we can see what it means. And there is even greater stuff, but this is the even crazier stuff that is happening on this system. And this is just the basics. This is like the idea of the whole thing. So, to start, I have got a couple things here. I've got warps, which can create a couple periodic functions. I've got a multiple here, because what I'm going to want to do is this right here. This Expert Sleepers ES8 is going to send it out to my oscilloscope. This right here is going to send it so we can actually hear what these sound like. This is a slide that I might give in a grade 11 class. In grade 11, we start looking at periodic functions. So one of the parts of it is the period or the cycle or the frequency. How frequently does it repeat? One cycle is the section of where it repeats. I'm going to patch warps into this multiple. And what I'm going to do is I'm going to come out of the multiple. And I'm going to plug into this. I haven't turned it up yet, so that we can hear what it is going to sound like. Now, let's also see what it looks like. So I'm going to grab another cable here and patch it into here for our oscilloscope. Okay, so there we have it. Let me turn this up. There is our sine wave. Want to make sure that we can, there we go. Now, I can cycle through a couple different periodic functions on here. There is a little bit more aggressive is a triangle wave. And I've got one more, I think, on warps, which is a sawtooth, which is even more aggressive. Now, that turns it off. Let's go back to our sine wave. What we study the most in grade 11 and grade 12, we talk about all these periodic functions, but we study the most a sine wave. Because it also deals with circles and other things like that. But you could have a whole ton of different periodic functions. For example, if I can hook up now, I said I was mostly going to stay on this top row that you could see up here. But for example, if I just hooked up for 1 second this module down here called chord, and maybe I'll run it into line 2. I'll turn off this for a second. This one is called a wavetable. So it's kind of all over the place with what it does. There on the oscilloscope you can see it in blue. Let's see what it sounds like. So there it is there. It's got a little bit more of a more interesting sound to it. And so some people are into wavetables, which it's still periodic. If you notice that thing that's kind of slowly passing by the screen there, it's a periodic function. It's just all over the place, kind of like that third one that we saw on the slides. Now, there were a couple things other than just periodic functions that we wanted to talk about. The first one was frequency. So how frequently I guess, the period or the cycle is. So how frequently it repeats. I'm going to get rid of this wavetable here off of the screen. And the way that frequency comes into it is exactly what you might think when you think of the word with music, is you've got high-end frequencies and low-end frequencies. So if I turn this knob right here on warps, it's going to change the pitch of that noise. And if you notice on the oscilloscope, I'm going to try and, there we go. If you notice on the oscilloscope, the sine wave repeats more frequently. So the frequency has been increased. And when we think of music, it's a higher frequency. All these words, like the meaning. So a higher frequency is got a greater, I guess the period is smaller, so it happens more often. And the reason why it's cycling, I can freeze it right here on our oscilloscope so we can see it. And a lot of the questions that we deal with in high school, it's a frozen snapshot of it. This is actually moving really fast if I change the time on here. But what is happening is I can try and adjust it. And if I can get the function moving at the same speed as the x-axis time, I can almost freeze it right on the screen there. Close. That's as best as I could do. Let's keep going. The axis of the curve, this is a key thing that we deal with. The axis of the curve in this one is right down the center of the curve, but we can adjust that if I change a couple things here. So this, I'm going to pull out of here so I can't see it for a second. I'm going to plug it into this. And I need one more little cable here to patch me over. Back in. What I can do with this module, this is an offset module and an attenuator module. So it looks the same, nothing's been changed. But the first thing is changing that axis of the curve. So with this top knob, I can offset things. And I've now changed the axis of the curve. It's so high it's off the screen there. I've moved the axis of the curve. And again, the axis of the curve, if we try and calculate from that middle line to the highest point and to the lowest point, it should be equal. So I'm moving that axis around with this offset knob here. But the axis of the curve helps us to figure out the amplitude here. Now, the amplitude is another important thing. I stumbled upon the amplitude while I was wondering, why is my oscilloscope not working? Now, the next thing was the amplitude. This is an interesting one. I believe it's this knob on warps, or I could actually do it with this knob over here on this offset attenuator to adjust the amplitude. I'm going to do it with this one so that we can actually hear also what's happening when I adjust the amplitude. And you can see the amplitude changing on the oscilloscope. Now what's super neat about that is the same wording. If we think of an amplifier, or is that sound amplified? It is exactly what we're thinking with amplitude. It's making it louder. It's making the sound louder.
And we can do that with any of them. Here's our triangle function. We can decrease the amplitude, decrease the amplification, increase it back. Our saw wave.
Okay, the next thing that we look at is we've got a regular sine curve here. That's this red one that's up on the screen here. This is the regular sine curve. We can do a phase shift or a horizontal translation, left or right. It can go either way, a phase shift of this. And what would that mean for the audio signal?
Okay. The next thing, I haven't tried this one actually out. This is our phase shift here. Now, what I'm going to do, let me see here. Okay, we've got our phase shift. I'm going to take this out of here. And I'm going to run this one into, this one says phase shift. I'm going to try putting it in here. Actually, I'm going to need another cable for this. Because what I'm going to do is, here is our original in red. Okay, now I'm also running the original into this phase shifter. And I'm going to come out of this phase shifter. And the second one on there, the yellow, is our phase shift. Now it's slightly shifted to the side. It almost looks like it is just negative. It very well could be, but we might be, ooh, that's changing the amplitude of it. That's the shift frequency. Oh, there's a phase shift right there. I'm not sure what it's been shifted over. Now the shift, well, I'm getting some glitching out on my oscilloscope here. The shift over is based upon, and it's moving slightly, is based upon, it's saying an LFO coming in. So if I took another function, like for example, maybe this wavetable down here, and ran it into the CV in over here, it would really mess that up. Now it's kind of jumping all over the place with our phase shift. Yeah, there's things bubbling and who knows what's happening. So we can slightly adjust that phase shift there, and oh, look at that, some really craziness is happening. It's almost ring modulating a little bit. With that other sound. So phase shift is slightly moving it left or right. Horizontal shift right there. Now we could do a whole bunch of different things with inverse, this module here called kink. Oh, we haven't been able to. Let's actually hear what this sounds like. Cool. Now that's with this one modulating it a little bit. If I take that one out, it actually sounds very similar. It's just slightly out of phase. And actually, let me do this so we can see what's happening here. I'm going to split this. So we can see, I believe, and I'm not 100% sure, if you notice when I turn off one of these two, not both of them, when I turn off one of the two of them, it gets louder. And I believe that is subtractive synthesis. It's when I had one of my bands mastered for vinyl, they said, you've got a phase problem. And if two things are slightly out of phase, like if we do this type of phase, where it was almost exactly opposite when we put both those in, it almost, not fully, but it almost negates the other sound, because there's a positive sound and a negative sound coming out at the same time. And I believe that's what a lot of people are talking about when they talk about subtractive synthesis. It's having a positive voltage and a negative voltage coming out, and they're kind of canceling each other out. We're still hearing some here because it's not perfectly opposite. And so we're hearing a little bit of the voltage every so often. Some super neat stuff. We can hear some craziness if we modulate it with another function, but that's for something else. That's combining a couple functions together. That's some advanced functions right there. Well, we might look at that in another video.
Now I've got a neat little thing here. If we put a negative in front of this sine curve, all the positive becomes negative. So if we look up here, the red is the regular sine curve. So 0, if we put a negative in front of 0, it's still 0. But if we put a negative in front of 1, it's a negative 1. 0 is still 0. If we put a negative in front of negative 1, a negative is a positive. We got positive 1. So changing the sign is kind of a neat thing. And we can do this with this little module right here called kink.
The only other real thing, let me see if I can do one of these quick, is, okay, so see again, it got louder. That's that idea of subtractive synthesis. So there's my regular sine curve. I'm going to plug this into here. There is my signal going in. That's just my regular signal. Now what this says is it's going to give me the negative of that signal. So I want to do a couple things. I want to see what that looks like. So the negative at a positive 1, or I guess in this case it's positive 3. The other one is at negative 3. At a negative 3, it's at a positive 3. The zeros stay the same. And let's also hear what that sounds like. So I'm going to also patch this in, and it should sound almost exactly the same as when we did it before. So it should, look at that. This one is a complete negative of the original signal, has completely canceled out our sound there. Both are playing right now. We are getting a full positive signal and a full negative signal at the same time, which are completely canceling each other out. That is pretty cool. Now there's a couple other functions on here. This function down here says keep the positive, but when it goes negative, just hang out at 0. Let's see what that one looks like. Cool, we can hear how it sounds also. So you can see the yellow matches the red up at the top. However, it hangs out at 0 and doesn't go negative with the function once it goes negative. There's one other function. Maybe we learn about it in advanced functions. I'm not sure. I haven't done that course in a long time. It's called absolute value. So whenever we see a negative 3, all those negative values would be pretty much reflected up into the positive values. This is almost like a wavetable, or no, wave folding. Kind of like that. And there you see it. There is the absolute value of this sine curve. That is combining two functions right there. That is some advanced functions. Now my oscilloscope is glitching every so often, so if you ignore that, the glitch, what you see on there is super cool, and we can freeze it to kind of look. This part that's coming down is absolute valued, so it's reflecting up instead. And as you can hear, that's what it sounds like. And it sounds quite different from the original. There's that absolute value one. There's the original one. Here's them together. Starting to get some interesting harmonics happening. Anyway, there are some of the absolute basics of when we look at periodic functions and how they apply. Everything that we're doing in grade 11 periodic functions, we're doing right here on modular synthesis. However, I bet you the math teachers don't even know about how it all applies to modular synthesis, and I bet you a lot of people who do modular synthesis don't even realize that they're doing periodic functions. There it is.